Hello geometry students, and welcome to our continuing series of videos on polygons and their inscriptions inside of a circle. So let's jump right into the next theorem here, which says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the radius is a right triangle. So there's actually two parts to this. There's the original part, which is what I underline in red, and then there's the converse, which is the rest of this. If one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle. Okay. So let me, I can actually capture both of these parts with a single picture. So let's say I have some circle here, and then I draw in a triangle. And draw slightly different. Let's say I draw in a triangle here. Okay. And we don't know, at this point, we don't know anything about the triangle yet. Okay. We don't know anything about the triangle. We just know that it's inscribed inside of a circle. Okay. And these are what the two parts are saying. The first part says, oh, let me share, I should name this too. Let's call this triangle A, B, C. So the first part of the theorem is saying if triangle ABC is a right triangle, okay, so if this happens to be a right triangle, then AC is the diameter, which in this picture would be the hypotenuse. Okay. Then the hypotenuse is also the diameter of the circle. So, in other words, given that we have a right triangle, this here must be the diameter. The second part of the theorem says something very similar. Well, it says the converse of this. If AC is the diameter, then ABC is a right triangle. Okay. If AC is the diameter, then the triangle must be a right triangle. And I'm going to prove one of these parts and leave it up to you to work on and study and prove the other one. But the ideas are all the same. You know, with proofs, we try not to memorize them, but rather learn certain techniques so that you can apply them in different situations. Okay, so I'm going to prove part 2 here. Given that AC is the diameter, show that ABC is a right triangle. So 1, AC is the diameter. Okay, that's given. Next, what I can say then is arc AC, this arc right here, is 180 degrees. So 2, the measure of arc AC is equal to 180 degrees, and this is just the definition of a diameter. Since you have a diameter here, then this arc must be 180 degrees. Well, now it's pretty simple. If you look at this picture, notice that angle B intercepts arc AC. Therefore, the measure of angle B is equal to 1/2 the measure of arc AC. And this is theorem 10.7. Okay. And note that angle B intercepts arc AC. Okay? So this angle B intercepts this arc AC, and this arc here is 180 degrees because this length is a diameter. So now we just have to do a quick substitution. The measure of angle B is equal to 1/2 times 180. Doing the substitution here. and that says that the measure of angle B is in fact 90 degrees, and we're done. Okay, so we have a triangle and we have a 90-degree angle, so therefore this definitely is a right triangle. Okay. So I leave this to you to prove part 1 on your own. Perhaps it'll show up on a test or quiz someday, but the ideas are very much the same. You don't have to memorize every individual step. Just think about maybe the main things that we used in here. As always, ask your teacher for help if you're having a hard time. Thank you for watching, and have a wonderful day.